Hi, and I want to welcome everybody to our Monday conversation with President Chris Maples. I'm Chris Maples, and today our conversation will be with Dr. C.J. Riley from Civil Engineering. C.J., tell us a little bit about your background and why you came to Oregon Tech.
I'm actually a founding member of the department. 1947.
Wow, you look remarkably young for that.
You wouldn't know it. No, I started here 3 years ago. Actually, we came in at the same year, and I've been teaching for 3 years. My background's in bridge design, software development, and got a PhD in advanced mechanics. So, yeah, that's me.
That's fantastic. And tell us a little bit about the department. How many faculty and students and the kinds of things that are going on?
Department's great. So we've got 5 faculty that are in the areas of structures, transportation, environmental engineering, and water resources management. And we've got a student head count of about 110 right now. We interact closely. The department, the faculty really get along well, so we tend to be able to do new exciting things every year. We're trying to develop the program, and the students, as far as we can tell, they truly enjoy working with us.
I will tell you, one of the things that has most impressed me about the department generally, and you in particular, is the interaction that I've seen that you've had directly with students overseeing the steel bridge competition and the concrete canoe competition.
Yeah.
Tell us a little bit about that. I think those are so cool, by the way.
Yeah, it's some of our favorite times is getting off campus. The students spend a good portion of the academic year designing the steel bridge and concrete canoe, which is often really confusing to people. Why would you make a canoe out of concrete? But we're civil engineers. The students, they like a challenge, and the concrete canoe has been around for a long time. So we have the students, they actually take the time out of classes. It's purely extracurricular. Yeah. They develop a mix design for the concrete. Ideally, it's less dense than water so that the boat floats on its own. They oftentimes have to add some foam, but they spend the time doing all that mix design. They get together. They have this one day where they all gather around the mold that they've created for this 22-foot-long canoe, and they're mixing the concrete and slathering it up there and trying to get it all to set just right. Let it cure for 28 days, head off to competition, and try and paddle it in groups of 2 and 4 against Oregon State, Portland State, University of Washington, schools all over Montana, Idaho. So they have a blast. And then the steel bridge, similar idea, but they design a bridge. Again, it's around 22 feet long. They fabricate it all on campus. They learn how to weld. They get really close, and they have a blast when they go to competition. Have to build it for time. And
cool. Well, I will tell you, having had the chance to go see the competitions, I was taken aback by the actual racing of the canoes. I mean, I thought that was actually really cool that they had to get in and paddle and race against all these other teams.
Yeah, absolutely.
Which, a proof is in the pudding of whether or not your canoe works well.
Yep.
I thought that was great. And I was really, really impressed with the steel bridge competition this past year, because you guys had a design unlike anybody else's. Everybody else had pretty much the same looking design, and you guys came out with something completely different. It was really neat, and it got a lot of the attention of the other students. I was sitting in stands and listening, and everybody was talking about your design.
Yeah. The other teams always come in with trusses. Trusses make a lot of sense, but students opted for a girder this year.
Cool. And
had a good time building it. They got disqualified, unfortunately, because it took them a little too long to build it. They had over 300 fasteners on it, but they put a lot of heart into that thing, and it was completely unique. It was the stiffest bridge at the competition, so there were some superlatives there for sure. It was great.
It was a cool design.
Yeah.
And it looked like it would take a load.
Absolutely.
There's no doubt. That's very cool. So what else is going on? Tell me about other student projects coming up this year.
Student projects, a lot of those are coming out of our clubs. So the
Okay.
Steel Bridge and Concrete Canoe are out of our American Society of Civil Engineers student chapter.
Mhm.
That's coupled with the Associated General Contractors student chapter. That club in particular does the Steel Bridge and Canoe, but then they do some work with cleaning up the highway in town. They do outreach in the high schools, and the canoe and bridge are really their biggest project. Engineers Without Borders is one that we really appreciate having. We started that chapter 2 years ago.
Mhm.
Since then, students have gone to Tanzania, Africa twice. First on an assessment trip, and then on an implementation trip where they've redeveloped pumps in different areas. Right now, they're working on design and implementation of a slow sand filter that would treat water for 40,000 people.
Wow. Wow, that's impressive.
Yeah. And so they raise funds, they travel over there, and they work with not United States grade construction equipment and put up some really, really important things. So
Well, that's a real world kind of application and situation. I mean, you can't have everything appear as it's going to be in a lab with perfectly designed everything. You make do with what you have. And
right. Nothing better than sending them off into a third world country and to see what you really have to work with.
That's
Absolutely.
really cool.
Yeah.
And just this past weekend, there was an unveiling near the department on campus. Tell us about that.
There was. Very exciting. So a project we've been working on for over a year now. Again, something that we actually started when I first got here. I think in that first year we were here, I asked you if we could put up a Steel Connections teaching sculpture. You thought it was a great idea.
Mhm.
We ended up citing that sculpture in a couple of different places over the years, and finally worked with a class, the Built Environment class taught by Mark Newpert. He had his students figure out where on campus would be best to put that sculpture. They picked a spot, and then later that year, Owens Hall was remodeled, and we very fortunately had the opportunity to work with 1% for Art funds that the Oregon State Legislature requires for projects like that. Gave us a small budget and an opportunity to work with an artist, and we asked this artist to take what has been a steel connection sculpture that allows students to get up close to steel connections and figure out how they work and look at them at full scale. Asked him to just tear this thing apart and do something more interesting with it, and he created for us what we call the basin.
Mhm.
And it's well, you've seen it now. It's three columns. It's a suspended element that represents the basin, represents all of the tension around water issues and natural resources that we have here, and I would also say it's an optimistic symbol for our community that we can balance those things. We can have equilibrium. We can have people working together.
Yeah.
So yeah, we dedicated that this weekend with visitors from Oregon State University, Portland State University, and University of Portland. We were
Terrific.
here for an engineering dinner, so it was a fantastic event.
That's terrific.
Yeah.
That's excellent. And so I get the impression that civil engineering is sort of all over the board here. I mean, you're a very active and very important component member of the sustainability committee on campus as well.
Mm-hmm.
So
Yeah.
it's what is civil engineering not? It sounds like it's everything in some respects.
Well, you mentioned I chair the sustainability committee primarily out of a passion for sustainability. I don't just want to teach it in the classroom. I really want this campus to embody everything that's possible in living within our means. And we do a fantastic job of that. This school was built on, as you know, geothermal energy and heating.
Right.
That's been with us for a long time. We keep developing that. We generate power now. We're looking at large solar systems. I mean, all of these things that we do to try and improve really our impact on the environment, and I think we're doing phenomenally well at it. And we like to teach that, obviously, in civil engineering. Nearly every discipline has something to say about sustainability, whether it's how we transport people, how we make buildings less impactful, how we deliver water safely and cleanly. Public health, safety, and welfare is our gig, and so making how we work with people. That's how we do our work.
That's really neat.
Yeah.
That is really neat. And another thing, since I've been here, I've had the privilege of being able to attend the ring ceremony.
Yeah.
Tell us a little bit about that, because you're wearing one of the engineering rings.
Right.
So tell me a little bit about that. I was not familiar with it before I saw it. It was really neat.
Yeah, it's the ring is something that at least mythically came out of a bridge failure in Canada, and during the construction of this bridge, a number of people died when it collapsed, and at least mythically, they started forging rings out of the steel from that bridge in order to have engineers remember what it is that they're working for. And so there are a number of these ring, let's see, what do we call them? You take the oath. So it's the oath of the engineer.
Okay.
And a number of groups around the country do this with their students every year. We do it with ours. And it's something that happens at the end of one's senior year.
Mm-hmm.
You take this oath, you basically vow that you're going to work for the health of the public safety. You're going to work ethically. All these things that we really teach during the course of 4 years here are really finally cemented when you get this ring and then realize that you're going to wear it on the pinky finger of your working hand, and every calculation that you do, this ring touches your paper, and so it touches the work that you do and ensures that you're going to consider all of those things and be ethical and be professional.
I love the symbolism of that. I really do.
Yeah.
And I love that it reminds people to be rigorous in their approach.
Mm-hmm.
And I'm actually very proud of the fact that what our faculty does is embody that in the way they teach and in the standards that they hold our students to. And yet the small classes give you an opportunity to work closely with students to get them through this rigorous program and not just throw them into deep water.
Yeah.
And maybe you can talk a little bit about that ability to really work in smaller groups and accomplish some things in that regard.
Yeah, well, you mentioned too just the idea of licensure, and when we're trying to get our students into professional practice, we want them to be as successful as possible. We do everything within our abilities to get them there and make them ready to practice right out of the box here. I think probably the biggest opportunity we have is what you mentioned there with small class sizes. I might have worked at a number of other schools, but I came to OIT because I wanted to be not only hands-on with the material, but hands-on with students. I wanted to know everyone's name. I want to know why they're here. I want to be able to give them the kind of education that they want, not the one that I think they need. And we end up with students who take that and run with it. They enjoy working with us. We have a blast working with them. We get into the labs. We just do everything in these very intimate environments. It's not large lecture halls. It's these small classes, and we can just interact.
And now we have a master's program on the board and headed our direction.
We do. We have a master's program approved. We're looking forward to offering courses at the master's level in the near future. It's exciting, and that's something that came out of, again, something we want to, if our students are going to be able to go out and practice immediately upon graduation here, we need a master's program in the civil engineering discipline. That's something that's that's been put out there by the American Society of Civil Engineers. They've got a policy statement that they want all of us working towards a master's as the de facto degree for getting civil engineering licensure. So a number of years ago, the department took it upon itself to ensure that we had that in place. It's approved.
Cool.
It's ready to go. And so
You
looking
tell me a
forward
little
to
bit
that.
about it. Is it going to be a thesis-based, project-based, applied sort of master's?
We've set it up so that you can do a coursework basis or you can do a thesis basis.
Okay.
So you can do either, and we're working to find a way to integrate that into our undergraduate curriculum so that it can be fairly seamless here.
Fantastic.
Yeah.
That's terrific. You have students working on a lot of different types of projects.
Mm-hmm.
Some of the things faculty are working on.
Faculty, so our main focus here, as you well know, is that we try to make sure that our focus is in the classroom. So all of our faculty are dedicated to our courses. Some of the side projects, if you want to call them that, this summer myself and another faculty in our department, David Thamert, went to the American Society of Civil Engineers Exceed Teaching Workshop. That's Excellence in Civil Engineering Education.
Okay.
I would say we both consider ourselves fairly good in the classroom, but you can always improve, and we wanted some more of those known tools to be better. So we went to this workshop. We got a lot of great tips, a lot of good ideas for the classroom. I think we're both trying to implement those this term, maybe to the chagrin of our students. They see us attempting things, and they're hopefully comfortable with that. We're trying new things in the classroom.
Well, that's got to be fun and
having a good
exciting
time.
for you guys too, though, to see how these things are going to work with students. And
Yeah, it's always that's another great thing about our students. They're comfortable letting us try things, and I think they appreciate that we try new things. That we're not just content to lecture at them. We want to try active learning methodologies and that sort of thing.
well, I'm fortunate enough when I'm here on campus to schedule time to walk around. And
Mm-hmm.
one of my last walkthroughs earlier this term in the engineering area, you were there with some of your colleagues working with students constructing Lego things. Tell me
Yep.
about that. That looked like a very interesting lab that you
Yeah,
guys were
that's
working
great.
on.
That's our freshman course, and
That's a freshman course.
that's a freshman
That's really
course.
cool.
I've taken that on with Jamie Zapay from Renewable Energy Engineering, and new faculty, Feng Shi, who's in electrical engineering. And it was just last year that we started this combined freshman experience where we got civils, renewables, and electricals all together, because we didn't really want to keep this idea going that you come here knowing exactly what you're going to do. So the students come into that program and they get to see that there might be other opportunities. Maybe I'm more suited to electrical, and they've got the opportunity to change their major. And we give them a good basis for that. So it's not just that they're thinking maybe that's the way I want to go. They understand what the electrical engineering discipline is and why they would want to be there, and vice versa, with the other disciplines. So yeah, what you walked through was one of our first just kind of group forming activities where we've got teams of students. We give them a light bulb. As Jamie Zapay, he did a lot of work for a time at NASA, and the light bulb is their astronaut, and they need to protect it through a landing sequence. And so they build a Lego capsule for the light bulb, and then launch it, and see if their light bulb lights up at the end. Their
How
astronauts
far do they
arrive.
have to
It's
launch?
2 stories.
And the light bulb has to survive and still
Light
work.
bulb has to survive.
And how successful were they?
It's funny. So the first group, they had all 5 they had a successful landing, light bulb lit up. That rarely happens. And then the next lab period, we only had 1. And we actually had one all-out failure where the astronaut was throttled a bit when it landed and hit the stairs. And
No.
it was terrible.
Okay.
But you learn more from your failures than you do from your successes. So
Well, yeah, and
that
talk a
group
little
learned
bit
a lot.
about that, because I often tell people when I'm out away from here that we teach our students to embrace failure and to
Mhm.
learn from that. Is that that's how you guys teach as well, as I understand it? At least
I wouldn't say we
least in
set
the
the
lab.
students up for failure, but absolutely, yeah. There aren't very many opportunities in engineering to design for failure.
True.
That's not what we're trying to do. But you get the most insight when you see failures. Our codes change anytime there's a failure
Mhm.
in practice. So, yeah, we give our students the opportunity to see steel ripping apart and explain, why is the failure surface like that?
Right.
What happened when we did that? You don't normally pull steel that far. We test concrete beams. For all I know, I think the electrical's wire circuit's wrong, just to show that you can fry something,
Right.
and you don't want to do that later on.
Well, it goes back to this oath and the ring in many respects, that there are people's lives that depend on the success and predictability on the engineering side of the house. I mean, you have your background in bridges as a really good example. You had a catastrophic bridge failure in Minneapolis a few years
Absolutely.
back.
Yeah.
You want to do those things in a lab and not in real life, because the stakes are much higher.
Yeah, and almost I'd say even better to look at those real life collapses. I mean, those are the failures that are driving our disciplines forward. And the lab is great because I can predict it. After a number of years in the lab, I know what's going to happen. I try to hold myself back. I don't tell the students up front how something's going to fail.
Right.
But yeah, it's even better when you've got something real life to look at and say, this was catastrophic, it was horrible, and it's a reason, one, to study what you're studying, and it's a reason to study it in a certain way.
So what would you say to students out there who would take a look at civil engineering and go, it sounds like it's pretty hard and it sounds like it's pretty boring? What would you say to somebody?
I love civil engineering. I think I can speak for our faculty in that we're all really generalists at heart. So I like learning about water. I like learning about environmental engineering. I like all of it. And to students who might come in thinking that civil engineering is one thing or another, some of my best students are the ones that stink at math up front. I mean, they struggle with it. They go up, they get tons of help. But in the end, maybe they were the ones that came in with a certain amount of heart, or a real reason that they wanted to study it. Or maybe they're just that student that knows how to read and write really effectively. Mm-hmm. And we can teach the math, we can teach the technical side, and all of a sudden they go out and they just astound us when they graduate with their ability to work with people. Because in the end, a lot of it is that, and we can get you up to speed with the technical stuff.
Fantastic.
It's
And
not that
there are a
hard.
lot of help
And
systems.
it's certainly not boring.
There's a lot of help systems in place to get students through here.
Yeah, absolutely. For one, we're given the opportunity to have plenty of office hours. We're encouraged to have that contact time with students. So it's not as though I go back to my office and close the door. That thing's wide open more often than not.
Great.
And I get students in there all the time. So first line of defense is me. But we're here in the LRC, Learning Resources Center, and the students have the Student Success Center here, where they've got tutors, they've got opportunities to understand how they learn and how they might need to test. And if that's different from other students, they're given accommodation. So, whatever it is that might trouble them along the way, they've got support here. It's excellent.
Cool. What would a civil engineer do? I've got my degree. I'm going to go out into the great wide world.
Good question.
What would a civil engineer do? Because I've heard of it, but I'm not sure I could tell you what all I would do as a civil engineer.
So I often say that civil engineering is infrastructure.
Okay.
So what is infrastructure? Well, it's everything you touch on the human scale in the course of a day. So you walk on pavements, Some civil engineer designed those pavements. You go through doors in a building, you get into a building, this thing's here, it's supported on the back of calculations done by a structural engineer, one of the civil disciplines. You drive down the road, you might get stopped at a stoplight. That might be kind of unfortunate for you, but you're sharing that road with a lot of other people, and a civil engineer's designed that intersection that you got stopped at to satisfy a lot of needs and satisfy them effectively. All of these things, roads, buildings, bridges, they're all supported on soils. So we study soils. You have to know that the ground underneath you is not going to fall away. You're on stable ground. We do a lot with soils. The environment in general. So water's a big one. Air quality, solid waste handling.
Wow. Wow.
We really, I like to say we really do it all, and it's everything at the human scale. And we tend to get our hands into everything. Anything you can see, smell, feel.
It doesn't sound boring at all, actually.
No, it's pretty exciting.
Okay. Well, that's very, even the chairs that we're sitting in here probably had some.
In a way, yeah. The training as a structural engineer could
Right.
tell you, exactly. You might, in fact, a civil engineering graduate might get into industrial design and ergonomics.
Yeah.
Because they've got that background. So no doors are shut to you.
That's fantastic.
Yeah.
I think that's great. And being a generalist in so many of those different areas, allowing you to apply what you learn and solve problems and to create some really new comforts or necessities
Yeah.
for civilization moving forward.
Yeah, absolutely.
It's got to be very gratifying.
It is. It's always exciting.
And do you hear from former students? Do they touch base with you? Do they let you know how they're doing? And
Yeah, actually, in fact, we just had some alums show up to this dinner that we had called the Host a Student Dinner. It's hosted by one of the 4 state schools with an engineering, civil engineering department, and we got the opportunity to host it this year. It's where we mix students and alums and professionals in the same room. We get them networking. The professionals host dinner, and we have a great opportunity to get our students talking to professionals about jobs, what they need to do. We had some great alums show up from just a couple of years ago. One's back. He's going to be working for Kiewit Construction.
Okay.
All over the world. He was talking about going to Brazil and Europe, and he's going to be working on oil platforms and doing engineering
Wow.
design of oil
Wow.
platforms. 2
Wow.
others had just finished their graduate degrees at Humboldt State and Georgia Tech in structural engineering and in environmental engineering. And I mean, you can't be more proud that you get to send your students off to really high caliber institutions like that. And they can come back and tell you where they're headed next.
That is very cool.
Yeah.
So we've got about a minute left.
Okay.
Any thought in particular that you would like to leave people with about you, civil engineering, our students, the program?
We like to tell folks that we have one of the best programs in the country. We stay on top of industry needs. We work with a very active industrial advisory council. We keep our eyes on accreditation. We're an ABET accredited institution so that our students can go on and get licensed. I think we've gone over this, but the biggest point is that you've got, at this school in civil engineering, you've got a really dedicated faculty. And we're all here for the students. We do things in the classroom for their good, and we do a lot behind the scenes to make sure that their degree is a quality degree that's going to be recognized when they get into industry.
Cool.
And that's going to serve them well when they sit down to practice.
Well, let me just add that you've accomplished an awful lot in 3 short years,
Appreciate
and
that.
we're awfully proud to have you as faculty here, along with the rest of the civil engineering faculty. You're doing
Thank you.
great things for students, and we're just delighted and really proud of what has been accomplished so far.
Appreciate
So
it.
thanks a lot. And thanks for joining me on Mondays with Maples. There will be more in the future, and we will have additional conversations. You'll get to learn a little bit about Oregon Tech, about our students, about our faculty, and about our whole hands-on approach to life. So thanks a lot.